density of liquids. Okay? So I'm going to start with vegetable oil. Not much is going to happen here because it's vegetable oil by itself. Okay? Alright, next, I'll use green. Alright, what's going to happen when I pour Palmolive, the dish soap, in?
It's gonna float.
It's going to float. Anybody think differently? Everybody think it's going to float. Okay, let's pour it in and see what happens.
No!
That I was gonna
Oh, yeah,
float.
because oil is heavier.
Give it a second.
Oil is what? Not that dense. It's not as dense as dishwashing soap. Okay? Alright, next I'm going to do Karo syrup.
Oh, that's
This is not maple syrup. This is not what you pour on your pancakes. It is basically pure corn syrup, which is basically pure, it's like a liquid sugar. What do you think is going to happen with this?
It's gonna sink all the way
It's
down.
gonna sink all the way down.
You think it's going to go all the way down? Okay, let's see what happens.
Above the dish soap.
If it sinks.
See, it's going to go above the dish soap?
Oh, nope, never mind.
Can you tell by the way it's pouring?
Yeah.
Yeah. We did something like this in 6th grade.
Oh yeah, it's very, very
I
sweet.
am.
How many of you like pecan pie?
Oh.
You know that middle gooey stuff that y'all like?
Oh my god, I love that stuff.
Karo syrup.
Oh
That's
no.
what it's made of. Okay, next one I'm going to do is alcohol.
It's gonna float.
What do y'all think it's going to do?
Above the green.
Above the green and between the...
All the way up to the top. It's water. It's water. See, it's water.
Alcohol is not water.
It's
Alcohol is alcohol.
How about that? Same density as water.
Yes.
About.
Okay, so what's the least dense of our liquids?
Alcohol.
Alcohol. What's the most dense?
Karo syrup.
Okay, now the fun one.
Blood.
Water.
Where do you think water's going to?
Very bottom, I'm calling it.
At the
Very
bottom.
top. Very top.
No.
Y'all think it's going to go above the alcohol?
It's gonna mix with the alcohol.
Above the soap.
Oh, you think it's going to mix with the alcohol?
Yes.
Yes.
What do you think?
Above the
It's going to
soap.
mix with the alcohol.
Above the soap.
It's gonna go everywhere.
Above the soap. So that would be below the vegetable oil, right?
No, it's not gonna go below
What?
the
Okay.
alcohol.
All right, let's see what happens.
Told you it was gonna mix.
It's not mixing.
It's not mixing.
Oh, I guessed it right.
I called it.
What? Oh, it's got Kool-Aid in it.
What did you call it, Ken?
It's got Kool-Aid in it.
Where did it go?
It went below the
I said above the
It went below the oil. Do oil and water ever mix?
No.
Are any of these liquids going to mix?
No.
No, because they all have different densities. So they're all going to level out. Okay?
I knew it was going to go below the oil because of that oil spill.
All right, now we're going to look at the densities, the actual densities of these, and you're going to label this in your journal. Okay?
Do I keep videoing?
Yeah, if you don't mind.
All right.
Okay? All right, the bottom, what was on the bottom?
Karo syrup.
Karo syrup. Okay? And the density of Karo syrup is 1.37. Okay? The next one was what? Here, I'll put this up so y'all can tell me. What was next?
So
Dish soap. Okay? And I used green on this one, so we'll color it green. So next was dish soap. And the density of that is 1.03.
Ooh. 1.03.
1.03 grams per cubic centimeter cube. Grams per cubic centimeter cube.
Okay.
Okay? Alright, what was next?
Water.
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 Water with
I'll
Kool-Aid.
do blue for water. Does anybody know the density of water offhand?
1.
1. 1.0. Okay? And next was vegetable oil. So we'll do vegetable oil
Which
next.
is 2.2.
2.7.
It is 0.91. and the last one was alcohol. What have I not?
86.
Okay, alcohol. And it is 0.87. So if I'm looking at these liquids, and I'm looking at the density of them, I'm gonna look at water, and I'm gonna think about other objects as well. If I have an object that is greater than 1, what do I know is gonna happen to it when I put it in water?
No.
If it's
Oh,
greater than
greater.
1, look at your liquids.
Switchmaker.
It's going to sink. Okay? So if it is greater than 1, the object will sink. If it is less than 1, what's going to happen to the object?
Don't float.
It's going to float.
I
Yes.
noticed when I put Kool-Aid in the fridge with ice in it and came back to it and it's melted, all the water was on the top.
And the ice did what?
Melted and created water, which then the Kool-Aid
Well, all it's doing is dissolving into the water. What happens to ice when you put it in water?
It
melts.
melts.
Good point. It
Float.
melts, but what does it do?
It floats.
It floats. But is it not the same substance?
It's similar, but it has ice, or it has
It's
air
more-
pockets.
What's
Physical
changing
change.
about
It's a
it?
physical
It's
change.
expanding.
It's
Water
expand-
expands
hang on,
when it
hang on.
freezes.
Megan, tell me what's happening.
The particles are more packed together.
Very good. Okay? Remember we talked about water in the liquid? They're moving all around the molecules, but as it freezes, they become very, very tight and they're packed together. And so ice floats in water because it becomes more dense.
But,
So if I
But-
drop a desk in water, would it
but,
float?
It's the way their atoms
What?
are arranged.
Yes, it's the way the atoms are arranged.
Boom.
And we'll learn that later, okay?
What?
Alright, you can stop.